All right, I think it's recording. If not, this is a test run. First, I'll show you the post test. So I've got that in here. That just sets all the different LED colors, tests the delay functions, and the logging string. This logging uses the UART. Yeah, so if these log strings in the power on self-test work, then the UART is working as well. So second, I'll show the test mode. I think it was currently running, so the output will be over here. There we go. So then it goes red, green, blue, and then runs the unit tests. And then if the tests failed, then there would be a red LED at the end, but it's just green. Okay, let's see. Debug mode, debug messages. Yes. So for the tests, I actually have debug mode on. I have the timestamp here. This took 3.6 seconds. And it says the debug mode, and then the function name, or the module name, and then the function name, and then whatever the log string is. But I will I'll switch to debug mode, and you can see that in action here. So let's see. I guess, yeah. Well, I'll do it anyway. This. There we go. I think we are in application mode. So you can see the status messages here was just the post, and the application mode stuff and debug stuff was talking about the LEDs. And it's got this timestamps here that are increasing as my application mode goes every 17/10 of a second or something. Yeah, report timer here. So you can see the timer increasing, and now these are all status messages. Okay, so from here I will go to normal mode. And to do that, I switch the build configuration, and I guess I'll show application mode. Right now I am in the polling mode, as I can tell by this define. And so just double check, make sure we're good before I build. Oh, no. Yeah, so with this undefined, then we're in application mode. So I'll do that again. Okay. So you can see the LEDs are changing, but you don't see the debug messages anymore because it's in normal mode. And then I can input character here, and the next time the report rolls around, it'll print out all of the characters for character. New test, it'll add next time that goes around. So that's the polling application mode. Next, I will try the polling echo mode. Okay, so power on self-test going, success, and then I can just type whatever I want, and then it gets echoed. Cool, and I guess I can show you the, well, I'll talk about the design in a second. First, I should do mode, the interrupt-based version of that. So I switch this define to be 1 to go to the interrupt mode. So I'm in the interrupt echo mode right now. There we go. There's the post. That's a success, so I can type anything here and it will be echoed. All right. So that's that one. Then I will do the application mode for interrupts. Click the terminal again. Okay, a little loud there, buddy. Okay. Thank you. Okay, so character, yeah, goes there. Test. Yep. So that is working for that mode as well. So I think now I talk about the design. So I have this UART interface here that I think is taken from an example from the Dean book. I kind of used that same similar deal. I have an init, a get char, put char, then you can check whether you have space to write or to read over the UART. You can put an entire string and just either call this in a loop or in the interrupt mode, it'll add the characters to the ring buffer or the circular buffer, and the echo mode is the interface that the application uses. I'll show you more of that code in here. I guess it's worth showing the circular buffer to understand the UART stuff. I've got just this struct. I think this is also, yeah, this is taken from that article that Dr. Montgomery shared. I've just got a opaque struct and a handle to it, and all these free functions deal with the handle. And I did end up doing the resize. So if you push and the buffer is full, then you can choose to call this function and the circular buffer will resize instead of doing an error. So the UART init is just pretty much taken from the Dean book. It all seems to work, and then it uses this flag here to tell whether you want to enable interrupts, and that will create the ring buffers, the transmit and receive, enable and disable the interrupts, and I have the LED functions inside of the transmitting and the receiving of characters, and I do this error reporting using a red LED for any of these error flags being set, which I think was 8. Let's see. So I showed the blocking and non-blocking. For blocking and non-blocking, I both cases use this echo interface, and if you have interrupts enabled, then we just read out of the receive buffer and write to the transmit buffer, resizing if we overflow. Whereas for the polling version, we use this get char, which checks whether there's an active data to be read, and then this echo just gets called, gets pulled repeatedly by the main function out here. So that's how the polling works. The application mode uses this when it's in application mode. It drops into this define block, and I use a scheduler to check whether the countdown timer has passed this threshold that I've set, and then it just resets to the current time. And so after a certain amount of time has passed, we output all of the characters that were added throughout the various echoes since the time passed. Extra credit. I think there's a bug I'd like to mention. In the polling version of my application mode, if I enter characters before the post test is finished, then it just freezes up. I have to wait until after the post test, and then I can enter characters. So that's a bug that I just kind of worked around. And I think that should be it. Thanks. Let me know if you have any questions.